Okay, it says which point on the graph y equals square root of x is closest to the point 7, 0. So, if we're talking about closest to, is that going to be a minimum or a maximum?
Minimum. Shortest distance.
If I'm closer, if I'm talking about like between the distance between me and you, and I want the closest distance, do I want the minimum distance or the maximum distance? All right, so the thing is, in this case, we're going to have to use the distance formula. And how many points do we need for the distance formula? We need 2 points. We know one of them is 7, 0. Now I have to figure out, if I take a point x and throw it into this equation, what's my y value going to end up being? The square root of x. So these are the 2 points. If I put x into this equation, which is just like f of x is equal to the square root of x. Say if it was 4, or 7, rather. If I put 7 in here, the y value would be square root of 7. So our answer would be x comma square root of x. Now the distance formula is equal to x2 minus x1 squared plus y2 minus y1 quantity squared. So let's go ahead and well, we got to do a derivative, don't we? Well, let's simplify it first, because it might be easier if we simplify it. And I'm going to run out of the box soon, but that's okay. Difference of x's is 7 minus x quantity squared plus. Now I'm going to do this. I'm going to say square root of x minus 0 squared. Does it really matter if you're going to square the answer? No, that's the nice thing about the distance formula. It doesn't matter if we went x minus 7 or 7 minus x. Since we're going to square it, we'll end up with the same number. And that's why I put the square root of x first, because what's the square root of x minus 0? Square root of x. And then square it, what do we get? X. So thankfully, that square root of x doesn't really make too much of a mess. So from this guy, I know I'm just going to get an x. Now here, I'll take 49 minus 14x plus x squared. And that's plus another x. So if I switch this all around, I'll get x squared minus 13x plus 49. Everybody with me there? I just rearranged this in the proper order. I haven't taken a derivative yet. I just simplify this down. And even better yet, if I do this, now I can just use a power rule with a chain rule, right? Everybody still with me there? All right, so now let's find d prime of x. Power rule. Because we're trying to find a minimum value. And so the way that we find the minimum value, take the derivative, set it equal to 0, and go. All right, so now in this case, I get 1/2 times x squared minus 13x plus 49. What's 1/2 minus 1? Negative 1/2. Now, times the chain rule, which is the derivative of all the stuff inside. Anybody disagree with that? 2x minus 13. Yeah, and it's not just x. It's x squared. It's a more complex function in there rather than just x. Now, if we rewrite this, and I know I'm going to set it equal to 0, and I know I'm going to get a big old fraction, that's 2 times the square root of x squared minus 13x plus 49. And in the top, I have 2x minus 13. Now, where is this going to be equal to 0? Sure. Better? Because we're finding critical numbers now. Because I have a negative exponent. Negative exponent. Yep. And that'll put that down in the denominator. All right, so now where is the, how am I going to figure out the 0? It's the numerator only. If I multiplied by the denominator, both sides, I get 0 is equal 2x minus 13. And for those of you who want to see the algebra there, if I go 2 times the square root of x squared minus 13x plus 49, and then over here, same thing, zero times that's going to be 0, isn't it? And these two things divide out, so I'm left with this. Add 13. 13 is equal to 2x. Then what? Divide by 2. X is equal to 13 over 2. So, how many critical numbers do I have? 1. The other point that I have to find is, are these where these would be negative. So optimization problems, calculators. Trust me, you'll be using a calculator for this. So I'm going to delete everything off of there. And what I'm trying to do is I'm trying to find out where the denominator is equal to 0. So I'm just going to graph that crazy square root, because that's really all the part that's equal to 0. Does that make sense? So I just want to find the zeros of that denominator. So I'll get x squared minus 13x plus 49. Because the 2 isn't, well, it is essentially inconsequential. But if I multiply it by 2, it shouldn't matter. And I'll go ahead and I'll be complete. Does it hit? No, we can tell just by here that the parabola is going to be above the x-axis, so am I going to get any zeros out of it? No, so this number, thankfully, is always positive. So I don't have to worry about anything with that. So I only have one critical number. Well, we got to check to see if it is the answer. There was an x. The square root of x, quantity squared, is equal to x. So I had the first part plus another x. So I had negative 14x plus x, which is negative 13x. All right, that's almost 7, isn't it? 6.5. All right, so I should probably check. I'll put in 0. Yeah, let's put in 0. That's a nice easy one. And then here, I'll just put in 7. If I put in 0, this part's gone, isn't it? All right, so that part's gone, so I'm going to get negative 13. And it's always positive on the bottom, so it's negative over positive, which is negative. Critical number. 13 over 2 is 6.5. No, you do what you do with critical numbers. You were doing a sign test. So that's a test point. Here's a test point. Critical number. 13 over 2 is 6.5. Say that one more time. No, we don't want. It will be eventually once we find if this is going to end up being our minimum point. Then yeah, we're going to plug it back into the y equals square root of x to figure out the other point. If this is positive, if you plug in a 7, you're going to get 2 times 7, which is 14 minus 13, which is 1. So that's positive over something that's always positive. So that's positive. So I'm going from negative to positive, so it means it's decreasing to increasing. Did I get my minimum? Absolutely. So I have a minimum. I know my minimum now is that x is equal to 6.5. But what's y? How about that? Just leave it like that. That's an exact answer. And that would be your perfect. That would just be the perfect one for that.
How is that point closest to 7?
Because we took the distance formula, which is going to calculate all the distances between, and then we minimized it. We found the minimum value. And so since this is a minimum value, it's the minimum value of the distance formula, which is the distance between the 2 points. So optimization is just basically curve sketching. Or not even that, it's the first derivative test. That's all optimization is. And it's just applied to one of the problems that we're doing here.